Do you now hear? Okay. Very good. So, it's my great pleasure and honor to be the first speaker here at the Baltic ALD conference in St. Petersburg. I will be talking about the history of ALD, and this will be the end presentation of a project that we have been working on for 3 years with a large group of international volunteers. Will we be changing slides? Yes. So I realized that it's possible that not everybody who is here actually knows what ALD is. So I have just taken one introductory slide to bring you to the same level. So atomic layer deposition, it's a chemical vapor deposition technique. It's based on saturating irreversible gas-solid reactions, which are repeated to grow a film. Do I have a pointer, actually? You need to have a surface which has some reactive sites. Typically you use 2 molecules which react to grow the film. Thank you. Can't make it work well. The first reactant is here shown with the 3 balls, ligands. It could be trivalent aluminium, it could be something else. It is brought to the surface. Yes. And it reacts with the reactive sites, leaves behind a chemisol monolayer. In this process, it's possible that gaseous reaction byproducts are released. If it would be trivalent aluminium on an oxide surface, it would be methane. This reaction is allowed to go to completion, and after that there is a purge or evacuation step to remove the unreactive reactants and the gaseous byproducts. Then we bring in a second reactant, reactant B. It could be water, it could be raw aluminum oxide, it could be something else. And that reacts with a chemisol monolayer left behind by the first reactant, leaving behind another type of chemisol monolayer, and optionally releasing gases or molecules. It could be methane, it could be something else. And then there's again a purge or evacuation step. After this one cycle has been done, you have grown a tiny layer of the material that you want to grow, and you leave some reactive sites on the surface, which can again be reacted with the first reactant, and you can repeat this cycle as long as you want to grow a film of the thickness that you want. And the reactions have to be saturating. It means that when you look at the amount adsorbed, first sign, it first increases, then it settles to some constant level. It has to be irreversible, ideally, so that when you purge, this amount stays. And here is some experimental example of how the mass adsorbed behaves with time. This is called hafnium oxide process from Estonian researchers. So in the first reaction, the mass adsorbed increases. During the purge, it stays constant. In this case, it actually decreases in the second reaction step because the heavier chlorine molecules chlorine atoms are being replaced by lighter elements. And during the purge, again, the mass stays constant. And this cycle is repeated as long as you want. Many materials have been made by ALD. This periodic state table shows an overview which we created a bit more than 5 years ago of the different materials made. For each element, you have different sections, to indicate if oxides, nitrides, sulfur compounds, selenides, tellurides, chlorides have been made, or other compounds. And if there is a black background, then the metal itself has been deposited. I will not go through this in more detail, but you can find more in the reference. It has more than 2,000 references. Unfortunately, one was missing. I'm sorry, this is not doing exactly what I wanted to do. Right, there's this jumping back and forth. I have to point to that. Okay. I will just continue, and I'll say that one reference from Professor Frost was missing, which didn't come up in our literature search. ALD has been discovered twice, under different names. Atomic layer epitaxy in Finland in 1974, the patent was filed, and as you already heard, it has also been invented or developed, discovered here in St. Petersburg under the name molecular layering, Malkujärven Slaivania, in the 1960s. Especially molecular layering has remained poorly known and cited. And that is the basic reason why we have started a virtual project on the history of ALD to explore the early days of ALD, to collect information, to understand what has happened when I home. Are you changing there? Yes, okay. All right. So just to convince you that molecular layering has remained poorly cited. Now, our conference organizers know of this molecular layering. Many of you know about molecular layering, but in the world, many don't know. So here are examples of two highly cited reviews on atomic layer deposition by Claes Niels Niinistö, 2007, and by Stephen George, 2010. And this is the world's most cited ALD review at the moment. And they don't mention anything about molecular layering. They just say the history of ALD and ALD dates back to the 1970s in Finland. Well, in Finland, we have known about molecular layering. The left copy is from my own thesis from 2002, and the right copy is from a review chapter by Leskinen and Vitala from 2002, and atomic layer epitaxy and molecular layering, they are both given as alternate names to ALD. There is one thing that caught my attention in this review when I was reading it. Molecular layering dates back to old Russian literature. I can say that these words, they make me think a long time ago. Old Russian literature. How old? There are no references given in the review that you can look, so I could not continue that way. I went to IMEC, Belgium, as a postdoc. There, somebody brought to me an article called Early Work on Atomic Layer Deposition Cited by Malevin and Svirnov. Their references were given, and also an email address. So I wrote email to Malevin, and he sent me copies of those early works. So I got started in digging into the history of ALD. And at that time, I was writing a review article. So I noticed that when I dig more into the history, I find more. It never stops. So I decided at some point I had enough. I will stop. So I made a table to the review some Soviet-Russian ALD investigations. I hoped that other people would continue the work, that this would convince them that there is something significant. And in the review, what I wrote, according to the more commonly acknowledged origin, ALD was developed under the name atomic layer epitaxy in Finland, and the less commonly acknowledged origin dates back to the Soviet Union, 1960s, the group of Professor Aleskovs. My review used to be the world's most cited review for quite some time, ALD review, until George review took the number one place. But you see that still, even though it was published in a good place, has been cited well, it didn't change the view of people. So I left the subject of history away for many, many years. I thought I'd done my part. But then it appeared in 2013 that in the internet you find that people say that there are these early molecular layering papers by Kaltsov from early 1960s. I didn't know what they were. I had looked into the history. I knew there's a conference paper from 65. That's the earliest that I knew of. So, from early 1960s, I wanted to know, I wanted to see So I asked the question in LinkedIn, and lively discussion followed, 25 comments. You can view the thread there. So, with a group of people, we discussed how to find these things out. And we came up with a virtual project on the history of ALD. We wanted to know, how was the concept developed? What were the first ALD experiments? When, where, and by whom were they made? Why were they made? We should collect together references to all early ALD publications. We should read it, we should comment on the work, and we should share our comments with other people. We decided that we will stop at 86 because you can't do everything. 86 is the year when the first review has been written of the atomic layer epitaxy works by other than the original inventors. We also realized that we are dealing with a sensitive subject, and we declared right away from the beginning that we need to work in an atmosphere of openness, respect, and trust. We wanted to know it all, and had to respect all people, all works, and to trust in people to have these details come out. And we started a file called ALD-history-evolving-file. Here we collect the basic information of the references and the comments and some other things. And this has now evolved for more than 3 years. At the moment it's 300 pages long. I took a PDF of it not long ago. It's there, it's for everybody to see all the time. We created this, or came out with this VPHA just before the ALD 2013 conference, and I was lucky enough to convince, at very, very short notice, Professor Kim, who was the chair there, to make a general announcement of the project, because we wanted to have general attention. We wanted to have as many people as possible participate. At that conference, I also heard that there are actually history activities going on. And it came clear that there's Professor Parsons from USA. He's writing a review on the history of ALD. Well, we got very curious, because at the same time as we came out with the project, and 2 or 3 weeks later, the review was published in Journal Vacuum Science and Technology A. I knew that it's also about molecular layering, and indeed, they say, ALD principle was first published under the name molecular layering in the early 1960s. However, they also said a planar thin film was not produced or evaluated. Well, this last statement is incorrect. And these authors obviously did not know it at the time of writing the review. If they did not know, these are very, very well-known people in the ALD world. If they don't know it, then there are many others who don't know. The history project was needed more than ever, I would say. So now I'm going through the big steps of advancement in the history project. You can actually follow up there the different years where we are going. So the next big step was that we came up with a publication plan. We have updated 2 times afterwards. So I will not go through it in more detail. I'm just saying that we are about done with it at the moment. You can view all the different versions on the internet. Then the next big thing was that I got a chance to visit St. Petersburg. I knew very well it's in St. Petersburg that the molecular layering has been developed. I had never met any of these people. Now I was invited to talk about history and collaboration at the Benek App Lab opening at Leti, same organizers as today. And while I came to St. Petersburg, I desperately wanted to meet the key people. It was Professor Grosz who came to meet me at the train station. I got to visit his university, and I wanted to know about history, so he brought me a lot of history to see. And then I visited Professor Malekin's laboratory. In this photo, you see Professor Malekin and his colleagues and me Please go back, I explained the photos. And okay, and then the main thing was, of course, the presentation here at the The next big thing was the Baltic ALD meeting in Helsinki, which Marko Leskinen also mentioned a moment ago. There we made the first poster presentation from the history project, just about the reading progress. We also created an exhibition, 40 years of ALD in Finland, and this was presented at the conference. It's a photo is of me and Jaakko Niinistö, who were the main organizers, and many people helped. Big things were also that Suntola, who is the ALD inventor in Finland, and Rost, who has created the first thin-film reactors here in St. Petersburg, they both gave invited talks. Next summer, there was the International ALD Conference in Kyoto. I was invited to give a tutorial on history there, which I created, of course with pleasure. And we made two posters from the history project. One was about molecular layering only, and one was about the reading status and progress. And all the time that we have presented these, we have wanted to invite more volunteers to join the project. At the moment, we are 73. And also this Fin ALD 40 exhibition, it traveled to Kyoto. That's a copy of our exhibition there. In this Fin ALD 40 exhibition, one part of it was that I wrote up the story of Suntola, how he wanted to share the details of the evolution of atomic layer epitaxy. And that was published as a separate essay then in October, A Short History of Atomic Layer Deposition, Tuomo Suntola's Atomic Layer Epitaxy. And the next slide will show some photos from this. So there's Sven Lindfors in 1978 in a flow reactor where the zinc sulfide growth was demonstrated from zinc chloride and hydrogen sulfide. There's a photo of Suntola, Anson, Lindfors and Pakkala at the Society of Information Display Conference in 1981. There's a photo from MRS meeting in 1994 in Boston. This was the launch of ALD to semiconductor fabrication. This is where that started. And Suntola was awarded the European Semi Award in 2004. Here is the altmetric score of this essay at the moment. It's 22, it's pretty good. It has been picked up by Twitter and Wikipedia and 7 times cited so far. When it was exactly 40 years from filing of the first patent on atomic layer epitaxy, we released the exhibition material to the internet.